Hello everyone, and welcome to the Mat 211 review of Measures of Dispersion. My name is Julia, and I work for the tutoring centers at ASU. So, we want to calculate the expected value, variance, and standard deviation of the given random variable x, where x is the number of red marbles pulled from a bag after grabbing three marbles at random. The bag contains 3 red marbles and 2 green ones. So the first thing we need to do here is we need to determine what our probability distribution is. Now, let's first consider how many different ways we can choose 3 marbles out of our bag. There are 5 total marbles in the bag, 3 red marbles and 2 green marbles. And we're choosing 3 of these at random. So we know that there are 5 choose 3 ways that marbles can be pulled. Now let's consider the different values that x can take. First, let's look at x equals 0. So we can't actually have x equals 0 because notice that there are 3 red marbles and 2 green marbles. So even if we pull our first 2 marbles that we pull out of the bag are green, well, that leaves us with only red marbles to go. So we can't actually get x equals 0 or no red marbles. So we don't have to consider that one. Let's next consider x equals 1, meaning that we pull 1 red marble out of the bag. Let's first grab our red marble. So this would be, out of 3 total red marbles, we would be choosing 1. So for red, we have 3, choose 1. Then we can grab 2 green marbles to fill in our 2 remaining marbles that we're grabbing out of the bag. So that gives us, for our green, well, there's 2 green marbles and we're going to grab both of them. So that would give us 2, choose 2. So then there are 3, choose 1. Choose 1 times 2, choose 2, different ways that we could grab our one red marble out of the bag. So we can divide this by our total number of ways to grab 3 marbles in order to figure out our probability for x equals 1. So this gives us 3, choose 1 times 2, choose 2, divided by our 5, choose 3. And this is equal to 6 over 11, or 6 over 10. Nope, actually it's equal to 3 over 10. There we go. So that's our probability that x is equal to 1. We'll write this over in the corner here for now. We can make ourselves a table. So we'll say our little x variable here and the probability that big X equals little x, well, we can have big X equal to 1, and that's going to be 3/10 probability. So next, let's consider x equals 2. We'll erase this for now. So if x equals 2, then that means that we pulled 2 red marbles and 1 green marble out of our bag. So let's do, again, the red marbles first. Well, we have 3 red marbles to choose from, and we want to choose 2 of those. So that's going to be our red. And we're going to times this by the number of green marbles we pick. Well, since we've already picked 2 red marbles, we can only pick 1 of our green. So we have 2 green marbles to choose from, and we're going to choose one of those. Then we're going to divide this again by the total number of ways that we can pick 3 marbles out of the bag. So that'd be 5, choose 3. And if we do the math on this, this gives us 6/10. So we'll write that over here, 2 and 6/10. Next, let's consider when x is equal to 3. In this case, we have 3 red marbles, and we want to choose all 3 of those. So we're going to have 3, choose 3 for our red, times, well, we're only choosing 3 total marbles, and we've already chosen all those with our red. So we're going to have 2, choose 0 for our green. And we'll again divide this by 5, choose 3. Now note that 3, choose 3 is equal to 1. 2, choose 0 is also equal to 1. So there's only one way that we can choose all 3 of our red marbles, since we only have 3 red marbles. So we'll have 1 on top here times our 5, choose 3, which is equal to 1/10. Now, x can't be anything greater than 3 here, since we only have 3 marbles, or 3 red marbles. So we can't choose 4, and we can't choose 5 red marbles. So we're done figuring out our distribution. So now that we've figured out our distribution, we want to find the expected value. So our expected value, which is our mean, so we'll say this is a mu. I'm bad at drawing mu's, but pretend that's a mu. This is the same thing as saying our expected value of x. Those two are the same quantity. And this is equal to the sum of xi times the probability that big X is equal to xi from I equals 1 to n, where n is the number of different outcomes we have here. Well, we can see that we have 3 different possible outcomes. So n is equal to 3, and each of these little x's in this column represent one of our xi's. So we're just using, the little I subscript here to index these to make it clear for ourselves in this summation. So this is simply equal to our 1 times our 3/10 plus our 2 times our 6/10 plus our 3 times our 1/10. And if we go through and calculate this, this is equal to 1.8. Now notice that you can't really have 1.8 marbles, because marbles they're 1, 2, 3, 4. We count those, but this is okay that we get a decimal here because this is just an expected value. So it's okay if it's not a value that's within our actual, possible values of x here. So let's go ahead and write this up in the corner. So we have that our expected value of x, which is equal to our mean, mu, is equal to 1.8. Next, we want to determine the variance of our distribution. So variance, which we denote as sigma squared, is equal to the sum from I equals 1 to n, where n is again our number of different possible x values, of, oops, make those brackets, make this neater, of the quantity of xi minus our mu, our mean, which is our expected value, squared, times the probability that big X is equal to each of our xi values. So it's often easiest to use a table to calculate this. We can start with our xi values here, which are these guys. And we'll say 1, 2, and 3. We can fill in our probabilities. Our probability that x is equal to each xi here, which we know to be 3/10, 6/10, and 1/10. Now, we want to first determine the quantity inside here, our xi minus our mu. And remember that our mu is 1.8. So we have, for this first one, we have 1 minus 1.8. So this is negative 0.8. For our next value, we have 2 minus 1.8, which is 0.2. And lastly, we have 3 minus 1.8, which is 1.2. Next, we want to square these values. So, calculate the square here. So we'll have our xi minus mu squared. And this just means taking each of these values, plugging it into a calculator and squaring it. So we have for negative 0.8 squared, this is going to be equal to 0.64. Remember, it'll be positive because if we multiply two negatives together, they become a positive. 0.2 squared is 0.042 or 0.04, and 1.2 squared is 1.44. Lastly, we want to take this value here and we want to multiply it by our probability, just like we have up here. So we'll have our xi minus mu quantity squared times our probability that x is equal to xi, little xi. And so this is just a matter of taking this value and multiplying it by our probability. So in the case of 1, we have 0.64 times 3/10, which is 0.192. Then we have 0.04 times 6/10. That is 0.024. Lastly, we have 1.44 times 1/10, which is 0.144. Now, all we have to do is sum up these three values because we've calculated everything inside of the brackets here. Now we just have to use our summation here to add these all together. So this equals 0.192 plus 0.024 plus 0.144. And if we add those all up, we get 0.36. So that is our variance. We'll write this up here. Our sigma squared, which is our variance, is equal to 0.36. So let's erase this table, make ourselves some room. The last thing we want to calculate is the standard deviation of our variable x, random variable x. So the standard deviation, which we term sigma, is simply the square root of our variance, sigma squared. Hence, we use the same notation for them, sigmas here. So this just means that we're going to take our variance, which we calculated as 0.36, and we're going to take the square root of it. This is equal to 0.6. And notice that we take the positive square root. So technically speaking, 0.36, we would have, or the square root of 0.36, we would have plus or minus 0.6 here. So you could either have a positive or negative root. However, standard deviation is always positive because it is a measure of dispersion. So therefore it has to be a positive number. So we always take the positive root here. So that's it. We have our expected value, which is this, our mean here, our mu of 1.8. We have our variance, sigma squared, of 0.36. And we have our standard deviation, sigma, which is 0.6. So before I go, I just want to remind you all that if you're looking for any additional tutoring or academic support at ASU, you can go to the Tutoring Center's website, tutoring.asu.edu, to find all of our resources. Also, if you're looking for tutoring for your specific course, you can use our tutor search tool, which you can find off of our main website page here, or by going directly to the tool at this full link on the screen. So thanks so much, and have a great rest of your day.